Okay, guys, so I'm going to go over AMC 10B Spring 2021, problems 11 and 12. Number 11, Grandma has just finished baking a large rectangular pan of brownies. She is planning to make rectangular pieces of equal size and shape, with straight cuts parallel to the sides of the pan. Each cut must be made entirely across the pan. Grandma wants to make the same number of interior pieces as pieces along the perimeter of the pan. What is the greatest possible number of brownies she can produce? Okay, so basically what we have is like, so she's making these brownies, right? So we have this rectangular pan, right? And it's going to sort of be like cut up into some number of columns and some number of rows, all of equal size, right? And we want to make it so that the number of pieces that are along the perimeter is equal to the number of pieces that are inside the perimeter. So in the middle, right? So basically what I did was I said, like, okay, let's call the number of columns, we'll call it L for length, right? And the number of rows we'll call W for width, okay? So the answer we're trying to find is area length times width, right? Now, let's think about this. So what do we know? Well, what would be the number of pieces along the perimeter, right? Well, if we think about it, it would be equal to L plus W plus W, but we have to subtract the ones that are being double counted, right? Which ones are being double counted? The four corners, right? The four corner pieces get double counted, like, right? Because when you count like this length plus this width, you're double counting that corner piece. But then you're also going to do the same thing when you add this length. It's going to double count that one. And then same thing over here. When you add this width over here, you're going to end up double counting this one and this one. So minus 4, right? Or 2L plus 2W minus 4, right? How many pieces are in the middle? Well, if you think about it, we're subtracting, because if this is L, right? Well, we're taking away 1, 2 from the length, and we're also taking away 1, 2 from the width, right? So the area of the pink rectangle would be L minus 2W minus 2. So we need to find the largest value of LW that satisfies this equation. Now, I will tell you, I tried my hardest to find an algebraic way to do this problem. I actually started using calculus, even though I know calculus is not part of AMC. I thought maybe I could use calculus because we're talking about maximizing a value. But honestly, it turns out that really the only way I was able to do it was sort of a trial and error method, which I hate. I hate trial and error when it comes to math, but you know, AMC does love to throw in problems where you kind of have to use the answer choices. Unless, of course, if anybody can show me a better way to do this, please do so. But essentially what I did was I started by looking at like 64, right? Which I'm not saying is the right answer. I'm just saying, like, let's start by looking at 64, right? Could 64 be the answer? Well, what are different pairs that will multiply to 64? Well, you have 1 and 64, 2 and 32, 4 and 16, 8 and 8, right? But obviously these two situations can't be the case because if you think about it, in those two cases, there are no interior pieces, right? Those cases don't make sense because there wouldn't be interior pieces. So let's see if either of these two pairs could work. So remember, I'm trying out this formula, right? So it's like LW, right? So 2L plus 2. So let's try 8, 8, right? 2L plus 2W minus 4 is equal to L minus 2 times W minus 2. Is this true? 32 minus 4 is 28. 6 times 6 is 36. So that does not work. So this cannot work, right? What about 4 and 16? So let's try 4 and 16 and see if that pair can work. So remember, it's 2L plus 2W minus 4 equals L minus 2 times W minus 2. Well, in this case, we would get what? 36 equals 24. No, right? So clearly that doesn't work. Okay, so rather than show you every possibility, I'm just going to tell you which one ends up working. So if you look at 60, right? So it turns out the answer is 60, and I'll show you why. Because one of the pairs that multiplies to 60 is 5 times 12, right? So let's check out 5 and 12 and see if it works. So 60 equals 5 times 12, right? So 2L, 10, plus 2W, 24, minus 4 equals L minus 2, 3, times W minus 2, 10, right? 10 plus 24 is 34, minus 4 is 30, 3 times 10 is 30. We found a pair that works. So therefore, we have a 5 by 12 pan. So the answer is D, 60. That's the greatest possible number of brownies that we could make. Kind of tricky. I think that this problem frustrated me because I really want to find an algebraic way to do the problem. It's just how my brain works. And when I find these problems that the algebraic way just really turns into a mess, I don't know. It's just these aren't my favorite, but luckily this one wasn't too bad. It really wasn't. It just wasn't the worst problem. So, okay. Number 12. Whoops. Okay, number 12. Let n equal 34 times 34 times 63 times 270. What is the ratio of the sum of the odd divisors of n to the sum of the even divisors of n? This problem is a lot easier than it looks. Because here's the thing. Okay, well, let's start by seeing, like, can we break n down into its prime factors? That might be your first thought, right? We should do a prime factorization. Well, I actually already did that. And, you know, basically like knowing like this is 2 times 17, 2 times 17, 3 times 31, 27 times 10, which is 3 times 3 times 3 times 2 times 5. Putting that all together, you get this. We get 2 cubed times 3 to the 4 times 5 times 31. Oh, well, yeah, that's fine. Times 17 squared, right? So if we break n down to its prime factorization, this is what we get, right? Now, rather than try to find the sum of all the odd divisors, which could be a total pain in the butt, let's just call it sum odd, right? We'll call it sum odd. Now, let's just say like we have the odd sum, right? Like we'll, you know, just say it's like S or something, right? What would then be the even sum? Well, the sum of the odd sum just means the sum of all odd divisors, meaning leave out all the twos, right? So all the divisors you can get without having any twos as a factor, right? So now to get the even divisors, we just need to take all the odd divisors and multiply them by any power of 2 that we might have. So if we think about it, like one part of the even sum will be the odd sum times 2, right? But then we're also going to have, we can also multiply all the odd divisors by 4. So then we can add the odd sum times 4. And then remember, we also have 8 because we have 2 cubes. So we can also add the odd sum times 8, right? So it turns out that like we don't need to actually find the odd sum. We don't need to know that, because all we need to know is that to get the even sum, we just have to multiply by 2 plus 4 plus 8, right? And 2 plus 4 plus 8 is 14. So when the odd sum divides out, right, we're just left with 1 over 14, or a ratio of 1 to 14. So the answer is C. So again, more of a conceptual problem as opposed to like doing any tricky arithmetic. So, but I actually like this problem a lot better than number 11. So I like number theory. So I these kinds of problems are kind of fun. So, all right. In my next video, I'll be going over 13 and 14. Okay, so I hope to see you there.